Right now, something impossible is crossing our solar system. It shouldn't be here. It shouldn't be moving like this. And it definitely shouldn't be ignoring the laws of physics that govern everything we know in the universe. In 2025, for the third time in less than a decade, humanity is witnessing something that defies every model, every theory, every certainty we've built about how the cosmos works. The object is called 3I Atlas, and it's about to rewrite the manual. The question is no longer, are we alone in the universe? The question now is, what exactly is knocking at our door? Let's establish something crucial here. This isn't just another video about astronomy. What is happening right now, in this moment, as you read these words, represents a fundamental shift in our understanding of the universe. For decades, we operated under the comfortable assumption that interstellar objects were too rare to matter. Theorists even calculated we should see maybe one per century, if we're lucky. 3 objects in 8 years demolished that assumption completely. And Atlas isn't just more frequent than we expected. It's bigger, stranger, and it's forcing us to confront an uncomfortable reality. Maybe everything we thought we knew about how the universe works is fundamentally incomplete. Every telescope on the planet is pointed at it now. Every space agency is recalculating trajectories. Because Atlas isn't just an interesting scientific object. It's a messenger bringing news from a part of the cosmos so alien that it might as well be from an entirely different universe. The stakes here? Our very cosmology is on the line. The way we understand the formation of stellar systems, the migration of comets, the possibility of panspermia carrying life between stars. All of that depends on understanding what Atlas really is. And so far, it's not cooperating with any of our theories. Let me tell you what makes Atlas truly unsettling. When Oumuamua showed up in 2017, we caught it on the way out. It had already passed the sun, accelerated in an inexplicable way, and was escaping the solar system at 87 kilometers per second. We had data, but no context, no inbound observations. Just a strange object, elongated like a cigar, reflecting light bizarrely, and refusing to slow down when it should have. Borisov, in 2019, was different. Definitely a comet, with a visible tail and predictable behavior. Reassuring, actually. Proof that interstellar objects could be mundane. Then Atlas arrived, and everything changed. First, the size. The solid nucleus is potentially 11 kilometers across, 10 times larger than Oumuamua, 5 times larger than Borisov. This isn't a fragment, it's a giant. Second, the origin. Atlas doesn't come from the direction of Vega, like the other visitors. It comes from the galaxy's thick disk, a region populated by ancient stars and leftover objects from the primordial formation of the Milky Way. If the estimates are right, Atlas could be more than 7 billion years old. Older than our own sun, a traveling fossil from an era of the universe we can't even imagine. Third, and most disturbing, the trajectory. Atlas isn't simply passing through our system. It's executing a tour of the planets. It will pass 28 million kilometers from Mars, then Venus, then Jupiter. At just 53 million kilometers. And Earth? We'll be conveniently on the opposite side of the Sun when Atlas passes. Our telescopes will lose sight of the object precisely as it enters the inner solar system, in October, and we'll only see it again in December when it's already leaving. Coincidence? Maybe. But the coincidences are starting to pile up in a way that makes astronomers deeply uncomfortable. The scientific community isn't standing still in the face of this enigma. Every new data point about Atlas triggers a cascade of reactions and recalculations. When the initial speed was measured, astronomers immediately compared it with orbital models. Result: hyperbolic trajectory confirmed. Atlas cannot be captured by the sun's gravity. That was expected. What wasn't expected was the speed being significantly higher than Oumuamua's, implying an even more distant origin. When the coma was detected, spectrometers were brought to bear to analyze the chemical composition. The initial reading suggested vaporized water, consistent with normal comets. But later, analyses revealed spectral anomalies that don't fit neatly into the profile of any comet known in our solar system. Trace elements in strange abundances, isotopic ratios that make no sense. When the planetary path was mapped, orbital simulation programs ran thousands of scenarios. The conclusion was unanimous. Atlas will pass close to 3 planets in a row, in an alignment almost impossible to occur by chance. The statistical probability? Astronomical. Ironically, astronomical. And then came the most radical proposal. What if we intercepted Atlas? Orbiters at Mars could, theoretically, make orbital adjustments for close observation. The Juno probe, currently at Jupiter, could be diverted for a deep space encounter in the spring of 2026. But every proposal runs into the same problem: time. Atlas is moving too fast, and our windows of opportunity are closing quickly. Every action revealed more questions. Every answer triggered 3 new mysteries. This explosion of interstellar objects might be the best thing that's ever happened to modern astronomy, or it might be the worst. On one hand, we're living through a moment of unprecedented discovery. 3 objects in 8 years means the universe is far more dynamic, more connected, more full of surprises than we ever imagined. Atlas alone carries enough potential to answer fundamental questions about star formation, the composition of ancient protoplanetary disks, and even the distribution of heavy elements in the primitive galaxy. Every measurement is a scientific treasure. On the other hand, we're completely unprepared. Our detection networks were built to track Earth-threatening asteroids, not to capture interstellar visitors moving at escape velocity. We missed Oumuamua almost entirely. Borisov gave us more time, but we still didn't have instruments calibrated for ideal measurements. Now Atlas is here, and even with months of advance notice, we don't have a mission ready to intercept it. The uncomfortable truth is this: we're discovering that the universe is full of fascinating objects passing through our cosmic backyard, and all we can do is wave as they go by. It's like discovering your neighbor is an award-winning genius, but you never learned their language. Some astronomers celebrate. Others despair. Most swing between the 2 states daily. October 2025 will mark a critical showdown, not between Atlas and Earth physically, but between the object and our ability to understand it. As Atlas approaches the Sun, sublimation of the ice in its nucleus will ramp up dramatically. The coma will expand, more gases will be released, and ground-based spectrometers will have a brief window, perhaps only a few weeks, to capture chemical composition data before the object disappears behind the Sun. Teams at the Keck Observatory, at the Very Large Telescope, at Hubble and the James Webb are coordinating an unprecedented observational campaign. Each telescope has its specialty: Keck for high-resolution spectroscopy, VLT for precise photometry, Hubble for ultraviolet imaging, Webb for deep infrared analysis that can reveal complex organic molecules. The plan is ambitious. Capture Atlas's full spectrum across multiple wavelengths simultaneously, while mapping the distribution of gas jets around the nucleus, while monitoring brightness changes that might indicate rotation or fragmentation. If it works, we'll have the most complete characterization of an interstellar object ever achieved. A scientific triumph that will define the field for decades. If it fails, if a solar storm derails the observations, if Atlas behaves even more unpredictably than Oumuamua, if the window closes before we capture enough data, then we'll miss the best chance we may have in our lifetimes to understand where we came from and what else is out there. It's a race against time, and the clock is speeding up. December 2025 will arrive with revelations or frustrations. Possibly both. When Atlas reappears on the far side of the Sun, it will already have passed its perihelion, the closest point to the Sun. If it survives intact, if it doesn't fragment under gravitational and thermal stress, we'll see a transformed object. The sublimation rate will be at its peak. The coma will be immense. And the data we capture in those first weeks of visibility will determine whether we solve the puzzle or sink even deeper into the mystery. Here's what's at stake. If Atlas shows chemical signatures radically different from what's expected, we'll have to rethink fundamental models of planetary formation. If it demonstrates inexplicable accelerative behavior like Oumuamua, the nitrogen comet hypothesis will be strengthened. But it will also open questions about how many other invisible objects are crossing our system undetected. And if, against all odds, Atlas exhibits features that cannot be explained by any known natural processes, well, then the conversation changes completely. The irony is that even now, writing this months before the event, we already know the story won't end in December. Atlas will continue to be observed as it recedes, fading gradually until it becomes invisible even to our most powerful telescopes. And then, sometime in 2026 or 2027, it will cross the invisible boundary where the Sun's influence ends and true interstellar space begins. And we will have learned something. Perhaps enough. Perhaps nowhere near enough. The lesson of Oumuamua is etched deeply into the astronomical community's memory. Missed opportunities are devastating. The object was literally in our cosmic backyard, and we let it slip away with virtually no proper study because we simply weren't looking for interstellar visitors. That failure is catalyzing change. The Atlas network, which detected the third visitor, is part of a global expansion of celestial watch systems. The Legacy Survey of Space and Time, which will begin full operations soon, promises to scan the entire sky every few days, detecting transient objects earlier systems would have simply missed. But detection systems solve only half the problem. The other half is rapid response. And here, the infrastructure fails. We don't have probes on standby. We don't have rapid mission protocols. Taking a spacecraft from conception to launch takes years, not months. The proposed solution is simultaneously elegant and frustrating. Keep pre-built interception probes on orbital readiness, primed to be activated and redirected when a new object appears. The cost? Prohibitive. The political will? Almost non-existent. So we learn, we tweak models, we publish papers, we update databases, and we wait. Because now we know something we didn't know before 2017. They will keep coming. The question is no longer if, but when and how many. We now live in a universe fundamentally different from that of 2016. A universe where interstellar objects aren't theoretical curiosities but observable realities. A stranger, more connected, more unpredictable universe than we thought. When Atlas finally fades from our telescopes, it will leave a complex legacy. It will have confirmed that interstellar visitors are common enough to merit dedicated infrastructure. It will have shown that objects from the galactic thick disk can and do reach our system, carrying information from epochs of cosmic history that would otherwise be completely inaccessible. And it will have left questions, so many questions. Why did the frequency increase so drastically? 3 objects in 8 years suggest a much higher rate than models predicted. Are we passing through a region of the galaxy particularly dense in interstellar debris? Has something changed in the local galactic environment? And what about the trajectories? Oumuamua and Borisov came from similar directions, aligned with the solar system's motion through the galaxy. Atlas came in perpendicularly. Does that matter? Does it say something about stellar streams, about velocity structures in the galactic disk that we haven't modeled properly? Answers will come, eventually. With more data, more objects, more encounters, we're only at the beginning of a new era of interstellar astronomy. An era that promises to rewrite not just individual chapters of our cosmic knowledge, but the entire index. And the next entry in that index could appear at any moment. It might be approaching now, still invisible, but inevitable. So, what does this mean for you? You're living in a historic moment. The first human generation to witness confirmed visitors from other stellar systems. Not in science fiction, not in speculation. In real time, with observable data. With objects you can point to in the night sky, if you know where to look, and say, that didn't come from here. The story of Atlas is still being written. Right now, telescopes are tracking. Scientists are debating. Models are being refined. And when December comes, when Atlas reappears on the far side of the sun, we'll be watching together as a piece of another part of the galaxy tells us secrets about places and times we will never be able to visit. But here's the real challenge. If we want to understand these visitors, if we truly want to decode the messages the universe is sending us through them, we need to be prepared for the next ones. And there will be next ones. Guaranteed. The question is, will we be ready? Keep your eyes on the skies. Follow the updates. Because the story of interstellar objects is only beginning. And Atlas is only the third chapter. The fourth visitor could appear tomorrow, or next week, or next year. And when it appears, when the alert goes off at observatories around the world, you'll know what you're seeing. It's not just a space rock. It's a letter from another solar system. And we've finally learned how to open the envelope. The universe is speaking. What remains to be seen is whether we're truly listening. Stay tuned for the next updates on 3i Atlas and the mysteries it will reveal. Subscribe so you don't miss the moment when astronomy changes forever.